The objective of this video is students will be able to recite the equations and related units of measure of objects moving with acceleration. They'll need paper and something to write with. Let's get started. We've discussed scalars and vectors so far, speed and velocity, distance and displacement. We've talked about the meaning of slope on a position versus time graph. In this video, we're going to discuss things that are moving with changing speeds. This is called acceleration. So there's a few different types of motion that can result in acceleration. When there's a change in speed, if you speed up or slow down, that's an acceleration. You can also change direction and still be accelerating even if your speed doesn't change. If there's a speed and change and direction, you can also have acceleration. In this picture, a toy car is moving along a track. The motion of the car is shown with a series of snapshots taken at 1 second intervals. The green arrows indicate the velocity of the car at each instant. The longer arrow, the greater the speed. On which sections of the track does the car accelerate? So on section A, the car speeds up as it goes downhill. This is a change in velocity, and hence the car accelerates. On section B, the car moves with constant speed in the same direction, so it's not speeding up there in the middle part. On section C, it's also accelerating, but in this time it's slowing down instead of speeding up. So as it goes back up the hill, it slows down and decelerates, which is also an acceleration. So it's answers A and C. Average acceleration is a vector quantity, just like displacement and velocity. This means it has direction and magnitude. It's defined as the change of velocity divided by the change in time. So that would be delta V over delta T, or VF minus VI over T. Or if you like words, average acceleration equals change of velocity divided by the change in time. And the units for acceleration are meters per second squared, or meters per second per second. Here are the equations for acceleration, and we're going to go over how to use these and when to use which one in class next time. For now, just get them written down so you're ready to go with those when it's time to use them. Each one of these symbols means something a little different. VI stands for initial velocity, VF stands for final velocity, A is acceleration, D is distance, and T is time. The units for distance are meters. The units for velocity are meters per second. The units for acceleration are meters per second, or meters per second squared. Time is always measured in seconds. The slope of a velocity versus time graph would yield units of distance over squared time, or meters per second squared, or meters per second. Since meters per second squared are the units for acceleration, the slope of a line on a velocity time graph gives us acceleration. Shown at the right are velocity time graphs for two different cars, A and B, and they're both accelerating. Is the acceleration of car A greater than, less than, or equal to the acceleration of car B? If you said that A had more acceleration, you would be wrong. It's B. Because B has a steeper slope, and the slope of a velocity time graph tells you how much the acceleration is. A is moving faster than B, but B is speeding up at a faster rate. That's it for this video. Make sure you take the Edmodo homework quiz and bring your notes with you to next class to help on the open note quiz. Thanks for watching.